Okay, so the last problem that was that we wanted to kind of look at how we can make a perfect square of 89. And we're given a bit of a hint here that 25 is a perfect square and 64 is a perfect square, and those add up to 89. So I've drawn out a 25 square and a 64 square, and what we were talking about before, and I don't know if this is going to always work, but it seems like if I use this right triangle, this is a 5 by 8 triangle, and I make a square off of this diagonal here. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. So it's going to go, I'm going to go 8. Yeah, so it's going to go 5 and 1, 2, 3, 4, 5, 6, 7, 8. If I use that right triangle, I can get the right angle corners. Okay, and so I'm just switching the x and y. So this is 5 and 8. I go now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. And that gives me the other corner. Okay, and again, it's to do with this right triangle inside that helps me calculate the areas. And this triangle seems to be able to give me the 89 units that I need. So this is going to be 5 times 8 divided by 2 is 20, 20, 20, 20, and that gives me the total area of 89. Okay, and that is, now I can use these squares and make a right triangle with these edge lengths, and the diagonal length should add up to these two squares. Okay, so the diagonal square is going to add up to those two squares. So it says here, try to draw two more non-perfect squares and calculate the area. So I'm going to just do randomly here. I'm going to go 1, 2, and 1, 2, 3, 4, 5, 6. Let's go 2 and 6. And that triangle is going to help me draw another non-perfect square here. So I'm just going to go 2, 1, 2, 3, 4, 5, 6 to get the corner here, and that gives me the right angle. And then I'm going to go 1, 2, 3, 4, 5, 6, 2 to get the other corner. Okay, and there it is. So I notice that that triangle I use is that triangle that shows up inside the square. So this is a 2 and 6 triangle. It gives me 16 units in here. It gives me 6, 6, 6, 6. So that's going to be 24 plus 16, and that's going to give me an area of 40 units squared. Okay, I'll draw one more here. I'm going to make it a little bit smaller just because I can't fit it in. So I'm just going to go 3. I'm just going to draw an outline of that. So I'm going to go 1. I'm going to use 3 and 1, 2, 3, 4, 5. Let's go 3 and 5. Okay, and then I go 3 and 5 to get a corner. I'm going to go 3 and 1, 2, 3, 4, 5 to get the other corner. Okay, sorry, it's going to go 3 and 5. It's going to be right there. Okay, so that corner there. And again, that's going to give me 3 and 5. 1, 2, 3. Oops, hold on here. 1, 2, 3. 1, 2, 3, 4. Ooh, that one was wrong. Okay, I'm going to have to do this again. So I'm going to go 3 and 5 to get one corner. Okay, so there's my edge length. 3, 1, 2, 3, 4, 5. 3 and 1, 2, 3, 4, 5. That gives me that corner, and that corner, and that corner. And again, I've got my diagonal square, and it comes from these triangles, this 3, 5 triangle. Okay, so this 3 by 5 triangle is going to give me 7.5, 7.5, 7.5, 7.5, and 4. So it's going to give me an area of 35 units squared. And the thing that we're now looking at, and this is now going to be what we're looking at, going to investigate a little bit more next time, is that this diagonal 34 squares seems to be calculated from these 9 squares here and these 25 squares here. These two squares seem to be able to give me the long square. So we see that there's these two smaller squares, we'll just call them A square and B square. They seem to give us the area off the diagonal square, which we'll call C square. So we're gonna investigate this a little bit more. Now for today we're just still looking at the length of the edge, the edge of the diagonal squares. So we still need to somehow calculate the area of these diagonal squares, and we're going to square root to get these side lengths. Okay, but there seems to be some other relationship going on here. We want to maybe start taking advantage of that.